Welcome, everybody, to episode 9 of the Technologist Podcast. With me today is Jason Gorman. Jason, hello.
Hi there.
Jason, you've been in the industry more than anybody that I know that teaches and practices TDD, I would say, religiously with...
I wouldn't say religiously. I teach it, and that's often mistaken for a religion. If you imagine if I was teaching Italian, and then there would be lots of people on Twitter or on LinkedIn saying, but I don't want to learn Italian. And I'm like, I'm not saying that you have to, but I teach Italian. And it's the same with TDD. I'm not saying you have to do TDD. I've never really tried to sell it to anybody. But if you want to learn test-driven development, or if you want to get better at it, then I might be able to help. But no, it's entirely optional as far as I'm concerned. But if you don't want to learn it, then there's not much I can do to help you. So
what's the sort of learning curve look like? Like, do you to be clear, and I want to use an analogy here. If I look at it as an investment advice, is it something that generates money or something that saves any phantom costs?
The learning curve for test-driven development, this is probably true of a lot of things that take a while to learn. The learning curve for test-driven development is often mistaken for test-driven development. So you'll get teams who try it for a few weeks and then go, well, we tried test-driven development. It just took us so much more time and it was so difficult. And and they come to the conclusion that TDD doesn't work because they don't really get past that. Now that gets me into trouble occasionally when I say, well, look, maybe keep going, keep learning. I think the advice that I give when I'm training people, when the people are being introduced to TDD, is to have realistic expectations. It's not going to change everything overnight. You're not going to master it overnight. If you really want to learn it, put aside some time every week or a bit of time every day to practice it more and grow comfortable with it and grow more, confident with it. And then people tend to find that after typically 4 to 6 months of regular practice, that it can become their default way of working, in the sense that a lot of what test-driven development is habits. Always writing the test first, little habits that help, like running the test to see that it does fail when the result is wrong, so it's a good test, and so on and so forth. And it's like learning a dance, I suppose. You'll often see people who are learning a new dance or haven't really danced before. When they're practicing, you can often see their lips moving as they sort of count. They go 1, 2, 3, 1, 2, 3. And TDD, when you're learning it, when you start out, it can feel a little bit like that. You're having to remind yourself to do these things. You're having to count, basically, as write the failing test, see the test fail, etc., etc. So they're kind of at the start, they're having to remember to do things. And I think what I've seen so many times is it kind of clicks for people when they're no longer having to remind themselves to do these things. It just kind of happens. And then they can get back to thinking about the problem that they're trying to solve, because the practices kind of take care of themselves. I mean, it's never that straightforward. You do have to think, but nowhere near to the extent that you're having to remind yourself to do basic things. And that takes quite a lot of reinforcement. So you need to go through that cycle, that red-green refactor cycle, many, many times, hundreds and hundreds of times, for it to really sink in. In the same way, when we first locked down here in London in 2020, all the pubs closed, which was a tragedy for me. All the pubs closed. And when they reopened, only pubs with outside seating, with beer gardens and that kind of thing, were allowed to open, and we were not allowed to go inside. So they all very hastily threw together these apps or these websites where you could order drinks and meals online. And so and I'm not going to say how often I go to the pub, but let's just put it this way: after a couple of weeks, I knew all my credit card details by heart. And TDD is a bit like that. I think any practical discipline, whether it's TDD or playing the piano or whatever it is, any practical discipline, takes a lot of reinforcement. You have to get to a point where you're not thinking about, if you're playing the violin, you're not thinking about so much about how you're holding the bow, you're actually thinking about the music you're trying to play. And I think if you can get people to that stage where they're not thinking about red, green, refactor, they're thinking about what is the problem we're trying to solve for our customer today. And the red, green, refactor just kind of sort of happens.
You mentioned the guitar. I see you have a guitar sleeve in the background, and I saw you play on one of your videos. You mentioned it's like a dance, like playing an instrument. It's like learning something. Is there an element to muscle memory, to TDD, that can be learned
I wouldn't
separately?
necessarily. I don't think it's the same. It's similar to just remembering someone's phone number. It's not muscle memory. If you just dial in that phone number enough times. I was noting actually with a couple of friends of mine this week that I don't know anybody's phone number except mine. I know my phone number. I don't know anybody else's phone number because I've got everyone on speed dial. So I'm not reinforcing. This is one of the reasons why I have a problem with copying and pasting. I'm not a fan of copying and pasting code generally, and I try not to do it. But particularly because I'm often working with people who are just starting out in their careers as developers. So typically they're doing apprenticeships or they've been taken on as a junior developer. And I have noticed in the last decade, because I've been running Codemanship it'll be 14 years next spring. And I've seen sort of certain trends over those 14 years. One of the trends I've seen is that sort of junior programmers and apprentices and trainees, they seem to be learning slower and slower. And I think part of this is the amount of copying and pasting that's going on. For the same reason, I don't know my dad's phone number. Wouldn't have a clue. But we speak on a regular basis. I must have phoned him many, many times. But I've the equivalent of copying and pasting, basically, I've got him on speed dial. And so I've noticed that maybe there is an element of not so much muscle memory, but maybe it's important for things to go through your brain a bunch of times, and then you remember them.
The standard the process.
And I meet developers, for example, who've been programming in Python or Java for a year or more. And then when I say let's create a new class, and they don't know how to declare a class. And I'm like, how have you managed to get this far?
Yeah, because the editor does it for them.
Well, number one, either the editor does it for them, or I see this a lot. They'll go and find a class and they'll copy and paste it.
Yeah.
They don't know how to declare test fixtures.
I see that a lot in in the front end world, where they are so reliant on transliteration and generated code that they are finding an example GitHub project that has something similar, and then they yank it out and then they try to put it into their code, into the editor, and then adapt it rather than start.
So they've never done it from scratch. And to be fair, on a day-to-day basis, they might not need to do it from scratch, because the tools, in the same way that speed dial helps me, the tools will help them. But it can get in the way when you're trying to get them to do something new, and it's just not sinking in. And so, because we copied when I started programming as a kid, when home computers started becoming more popular, we copied and pasted code listings, but we copied them from magazines and from books. Yeah. So we had to read them and we had to type them in, whether we understood them or not. And I suppose it's a bit like when you're learning a language, if you just keep hearing it and repeating it, eventually the language center of your brain starts to kick in. And I think that there's an element of that in programming, that if you do it by hand a bunch of times, it will sink in much better than if you just copy and paste it or have it generated for you.
Nick Shoemaker is in chat, and he asked, that part which you mentioned, where you need to learn the discipline, where you're still actively thinking about doing the habit, building the habit. How do you sell that to management if you're doing that on the job?
Oh, I don't. I sell nothing. I made a promise to myself years ago when I started Codemanship to not sell it. And I very rarely interact with senior managers. They wouldn't like me very much if I did.
Interesting.
I find, because it's a small business, and I tend to find that when people come to me for training or for mentoring or coaching, they've already made a decision. They've already sold it to themselves. And therefore, I don't really need to sell it to them. I do try to set expectations. Look, this is going to take some time, but that's not really my problem. What they choose to do with it is up to them. I can't force them. I can't make them.
So, is there a litmus test? Like, if I put a engineering team in a black box, and I just give you analytics, or I give you telemetry about how this team behaves.
Yeah.
Can you tell whether they're doing TDD or not?
Oh yeah, I only have to look at their code.
What stands out? What is like a strong signal that they are or they're not?
The big giveaway is when there's not very many tests or no tests. So that's usually a giveaway. There are certain sort of if you do TDD sort of fairly rigorously, there are certain things that are going to happen. First of all, your test coverage is going to be very high, which is not a goal. You should never set out for that. But if you are only writing code to pass tests, it stands to reason that all of your code will be tested. So we tend to find, particularly, are you familiar with mutation testing?
I am, yes.
Yeah. So
you break something randomly to make sure that your tests are failing correctly.
Yeah. So mutation testing can be, we tend to find that code that is mostly test driven has high, what they call mutation coverage. That is, it is very difficult to break a line of code without any tests failing. So that's one of the self-fulfilling prophecies. So if their mutation coverage was low, and that's something I'd always be interested in looking at, I would suggest that a lot of code was not being written to pass tests. Now, if there's a lot of code that's not being executed at all by tests, that's a big giveaway that somebody somewhere was writing code that wasn't required. The other thing that tends to give it away is the code itself. Keith Braithwaite, who's done research when he was working for Zulka Engineering here in London, he did some sort of internal research on some of their code bases to compare code that was test driven to code that wasn't test driven. And aside from the test coverage, which is the big giveaway, he found that the code that was test driven tended to be simpler. And we've all discussed this over the years. Why is that? And I think there's probably a number of reasons. I think Steve Freeman, who co-wrote the book with Nat Price, Growing Object-Oriented Software Guided by Tests, his theory is that every piece of complexity you have to pay a test tax. You can't just add stuff to the code. You've got to write a test for it first, and therefore that discourages you from adding too much, from making it too complicated.
So you budget
complicated costs you a lot. Yeah,
you're incentivized to budget the complexity of your code.
Yeah, if you don't write code unless you mean it. Yeah. So when people say to me, for example, this code isn't worth testing, I'm like, well, then let's not write it at all then. Because you just told me this code isn't worth writing.
So when it's not worth testing, it's not worth writing because you're incurring.
Well, I mean, I'm being very, very.
Yeah.
But generally speaking, if we're talking about production code, code that gets used tends to get changed the moment you put it in the hands of end users. So if you're intending for your code to be used, you should be planning for it to be easy and safe to change. So you would want to have some kind of regression test coverage around it, some fast running tests. So it's kind of a giveaway. But when people say, "Oh, there's no point in testing these code," I'm like, "Well, are you planning on anyone using this?" There are always going to be exceptions to that. There will always be exceptions, but it's kind of a joke in that sense. So, but it's a joke with a serious point. And I think that when you're looking at code that has been test driven, you tend to find that people, when they write code, they really mean it. Basically, they're doing it like they really mean it. So that's one of the reasons why I think code that's test driven probably tends to be simpler. The other reason is you've got that built-in step to remind you to refactor the code. So you are looking to fight that complexity as you go.
Yeah. And
then the third reason is if you're disciplined about TDD, you're trying to do the simplest thing you can think of that will pass the tests.
And that's harder than it seems.
Is it harder than it looks? Yeah.
Yeah. Because when I'm coaching it, I generally, one of the most common conversations at the beginning of like a coding kata, like a TDD kata, is I know what you're trying to do. You're jumping too far ahead. Make it pass first.
Yeah.
Right? So because then in their mind, it's like, I'm going to change this and move that and move that. And it's 6 simple things. But then your cognitive load is like, okay, it's just these 6 simple things. And then Dennis is talking to me and my Slack notifications are beeping on my phone and the baby's crying and I get an email and something happens. And then we run the code and it fails and it shouldn't.
Yes.
And then we're like, and then whoosh, all that goes out of the mind.
Complexity is an interesting thing. We in the work that I've done over the years, and I've seen this from other people who've looked into this, we tend to find that things that make code easier to change tend to also make it more reliable. And complexity is the big one. The more complex your code is, the more things there are that can go wrong. The more moving parts in your machine, the more likely is your machine will break.
How does complexity manifest? Because it might be subjective, it might be unintuitive. For somebody who's coding for 4 or 5 years, how do they look at a piece of code and say, this is complex, this is not complex?
Good question. I mean, I would measure complexity these days in a kind of very general sense of the number of things that could go wrong. How much is there here that could break, that could go wrong? But there could be many different ways of looking at it. It could be size, big functions or methods, large classes. Mm-hmm. It could be logical complexity, so cyclomatic complexity, for example, or the number of possible combinations of inputs. So there's lots of potential different dimensions of this, but they all add up to the same thing, which is, they add up to 2 things. One is how much is here that could go wrong. Mm-hmm. The more there is that can go wrong, statistically, the more is going to go wrong, basically. But also how easy it is to understand. The more moving parts the machine has, the harder it is to wrap your head around it. My uncle Pete, bless him, who worked at IBM Research for many years. Mm-hmm. And one of his hobbies was he'd been doing it probably since he was a teenager, I don't know. One of his hobbies was to pull things apart and then put them back together. Motorbikes, stereos, you name it. And inevitably, there'll be a little jar of pieces it didn't really need. And then just as inevitably, a few weeks later, it would break down. Because he didn't really understand what those pieces were for. And code's a bit like that. The more complex it is, the harder it is to wrap your head around it. And the easier it is to break it. But it is a multi-dimensional concept. There's no one measure of complexity in software. There's all kinds of ways of measuring it. But
by the sound of it, you're measuring it primarily. My question is perhaps more to the sort of practical side of, can it be eyeballed?
Oh, yeah, I think it can. But going back to Keith Braithwaite again, he sort of asked me, he was talking about working with less experienced developers. And he said, well, how do you cultivate good taste in code? How do you cultivate good? So I've worked with developers who will look at a method that's 300 lines long and see nothing wrong in it at all. And so to some extent, you're trying to culture developers to know a code smell when they see one. And there are no scientific definitions of feature envy or long methods. How long is a long method? And some people will say, well, if it fits on the screen, and I'm like, well, I've got a 30-inch 4K monitor. I turn it on its side, I can fit a lot of code in that with a small font.
Surprisingly, from article writing, there is a lot of research on that specific part, especially when code is concerned. But not much. Even with cyclomatic complexity, I knew, I started doing that primarily like 20 years ago when we were still junior devs, sort of messing around with PHP 4, PHP 5. And even there, we disagreed, like, what is too much cyclomatic complexity? 5, 3, 7, 13? Like where should we stop?
It's interesting. So Microsoft, I don't know if they still support it, but they had a tool. I don't know if they developed it or if they bought it from someone else, called FXCOP. And it was originally a tool that was used by .NET developers for metrics and automated code quality analysis. And what I found interesting about FXCOP was, and very telling once I looked at the code for it, is that they sort of set their upper limit. Their warning bells would go off at a cyclomatic complexity of about 25 for a method.
Oof, that's a lot.
way off my scale.
That's way, yeah. That's like I
yeah,
get.
But then I read the FX cop. Then I read the FX cop code, and I thought, that's why it's so high.
Okay.
So they seem to have set their bars. So you can adjust them, you can change them and customize them, but they seem to have set their quality bars at how bad their code was.
Are you familiar with?
Because you know full well, if you write a linter or a tool that does code quality analysis, you know full well some smart ass out there is going to turn that tool on its own code.
Yeah,
and you can guarantee it. So they must have set their bars where they thought, well, our code is pretty bad, so we better set it here. But yeah, it's a question of taste. And as I get older, my tolerance for complexity gets lower and lower. But then you end up reintroducing different kinds of complexity, and this is where I sort of this is the challenge that I face as an instructor, is that I'm trying to encourage developers to write very highly modular, very highly composed code. But a lot of these developers are fresh out of university and they've never seen that. They're used to seeing all of the code in front of them, basically. They're used to seeing it all on the screen.
One whiteboard. Like that.
So the analogy I use, well, it's not really an analogy, it's probably true, is I'm taking all the complexity from that file we're looking at now, and we're moving all that complexity into the project window. So we're basically moving the complexity into the arrows. We're taking it out of the boxes and building it into the arrows. And that's what modularity is really about. But I'm aware of the fact that particularly inexperienced developers, a lot of them really struggle to wrap their head around very highly modular code. And it is hard to write because then you have to really choose your names very carefully.
You need to name 10 things instead of one.
There's nothing worse than having to go look inside every class to understand what it does, because it's so poorly named. So you have to put a lot of effort into making sure that at the bird's eye level, it all makes sense. You don't have to look inside those boxes to see what they're doing, unless you're planning on changing them. But that's hard. A lot of it is hard, and nobody said it would be easy. But TDD doesn't necessarily naturally lead you to higher modularity. That's one of those things that you have to bring.
I've noticed that.
Yeah, you have
especially
to bring
training it. Yeah, they will quickly go down this route of they follow TDD religiously or by the book, by someone's book, and then it creates code smell. Like they were sort of okay being chaotic, and then they start doing something and they follow it a little bit too much, and then it creates code smell, and then the discussion becomes very difficult to separate out. Hey, you're following TDD, great, but like you still need to design. You still need to think about the problem. You still need to solve the problem. You still need to name things well. You still need to TDD doesn't. There is no magical emergent design property coming out of the discipline itself.
Well, there probably is. I was saying on Mastodon earlier, someone was sort of saying, a friend of mine was sort of talking about, someone had said, I don't like TDD. I don't like what it does to my architecture. And I'd be very curious.
I've heard that a lot.
I'd be very curious to see that code. I think one of the, apart from the simplicity that it tends to encourage, I think one of the other things that if you're leading your design with unit tests, it's another sort of self-fulfilling prophecy, like high test coverage, is you're going to end up code that is easy to unit test, because that's where you started with a unit test. So you tend to end up with, in that sense, a better separation of concerns from external dependencies.
From what I've seen on the interface side, on the sort of design side, the public design side, I think TDD, I think the magic is really that TDD pushes a lot of the interface into the public domain. A lot of developers like having like one public small interface, and then they do everything privately. And then there's sort of the code smell happens in a private space. And then they get really uncomfortable when their APIs have to be a little bit more public than they're comfortable with in order to test it properly without resorting to end-to-end tests for regression.
Yeah, I mean, there are usually ways around that. I mean, tests can be internal in languages like Java and C#, for example. You don't have to expose things. You can make them visible to the tests. This is
But not
something
to
that's
the-
quite
yeah.
explicit in Swift and Xcode, for example.
Mhm.
You can say, well, these things are only exposed for the purposes of testing, or this dependency is a test
Mhm.
dependency, therefore this stuff
I really
doesn't
like
need to be
that
public.
particular nuance of
Yeah.
the sort of iPhone OS X space.
Yeah.
They really have a high nuance to modularity, but then when it goes to production, it gets locked down. So,
But you
when,
can do the same thing in a lot of different languages, and of course, if you're working in JavaScript or Python or Ruby, everything's public anyway. There's really no distinction. So, and there's a convention which is yes, you can see this. No, you're not supposed to see it.
yeah, same thing with
and
JavaScript and TypeScript.
Yeah, so then your client developers need to be disciplined about, oh, these are the features we're allowed to use, and the rest is there for other purposes. So it's totally get aroundable, but yeah, I mean, it maybe betrays the way that when they talk about TDD, very often what people really mean is unit testing. So when people say we do TDD, what they mean is we write unit tests. And they're often coming at from the angle of all the units need unit tests. So I've had very interesting, energetic debates with people on training courses. There was an American chap who came over, worryingly, from a company that trains people in TDD, who said you had to have tests for all your getters and setters. Now, my first thought is, why do you need all those getters and setters? Which is a separate discussion. But also, I totally disagree that the purpose of unit tests is to test every unit. You could easily redefine a unit test as a unit of behavior, that you have a test for every end user outcome. And that would necessarily have to be tested from the outside. You make it visible, observable from the outside, which you probably want anyway. Some kind of feedback mechanism to let the end user or the external system know, okay, and you got the result that you asked for.
So for the result jargon, is that a technical problem? Is it a product problem? Business, we tend to name things, but then we write tests for, there's a payment processor class that has a reconciliate function, and then we create a payment processor test that has a reconciliation procedure method, and then it creates that brittleness, that goop of, I have a class with a method and I create a test suite with a test in it.
Well, when you sort of follow that route, when I mean, in the 90s, especially when I was, earning my spurs, I did that many times. But it tends to lead to a situation where your test code is sort of sticking to the internal design, like melting cheese into a radio. It's like melting cheese into a radio. It just sticks to every component and makes it very hard to maintain your radio.
I like that.
So you want it, on the one hand, you kind of want the best of both worlds, in the sense that you want your tests to be as decoupled from the internal design as it can be, so that as the internal design changes and evolves and you refactor it, you're not having to rewrite a whole bunch of tests. But at the same time, when you sort of do, I call it sort of pinhole tests, where you're testing through a pinhole in an API, when there's a really vast system underneath that pinhole. And then when your tests fail, you inevitably end up in the debugger going, yeah, but where is it going wrong? Where in this enormous call stack? So the other thing you have to watch for is when your test code gets too many layers away from the code that's being tested. I had I bought a new gas cooker a couple of years ago, and I paid Currys, I'll name them, I paid their know-how team to install the gas cooker for me. And these two guys, they turn up in their van, and first of all, for safety, they have to take a gas reading, a pressure reading at the gas meter at the front of my house. And they said, unfortunately, we're not able to install this gas cooker because there is a gas leak somewhere in your house. Now, you don't really want to hear somewhere in your house. At the very least, you'd like to know which room the gas leak is in, so that you don't end up ripping up all the floorboards, ripping out plaster on the walls, etc., to try and figure out, okay, where is the leak? Luckily, it turned out the leak was in the gas meter, so someone just came and replaced the gas meter. But you don't want tests failing and essentially telling you there's a gas leak somewhere in this house. Something in this big call stack is broken. Now you go find it. So you kind of have to find a balance. And one of the ways that I visualize that is if you sort of imagine, even if what you're working on is a big, monolith in that sense, it could be a very modular monolith. And if you imagine your monolith, maybe there are thousands of classes, but if you imagine those thousands of classes breaking down into small clusters, and each cluster has a very small, simple public interface, a bit like a microservice. And then hidden behind that is the details of how it works. So I would typically write unit tests around these interesting clusters. So not at the level of individual classes, but at the level of a collaboration of classes that are doing one specific job together. So that when that test fails, it's at least leading you to, okay, that's the room that the gas leak is in. So you're having to strike this balance between keeping your test code away from the internal details, but also recognizing that there are going to be stable interfaces in your design that aren't going to change much. And maybe you could write tests around those so that you've got these little packages of classes or packages of modules or functions, and you can identify the problem is in here. And then any other packages that it's interacting with, I would typically stubble mock those. So my tests, unless I'm writing specifically integration tests, my tests are about the job that's being done by that collaboration of classes.
I saw Milan Milanovic from Silicate post about Arc Unit, I believe it's called, where you can write a test that claims these clusters of classes should never publicly communicate with those clusters of classes. So they're sort of holding you accountable to the exposure and the modularity of your units, or at least to your modules, in regards to the conventions of the language that you're using. You might be using public interfaces and packages or protected methods in Java, but those might not be enough. You might actually need tests to express the sort of relationship between your architecture pieces more explicitly, to then be able to communicate with the team that, hey, like, regardless of what the language convention is, we should be held accountable to a higher standard, to a more expressive avoidance strategy for code smell.
Yeah, I mean, that's where discipline comes in, and it's particularly important. I think if you're working in dynamic languages that don't support any of these concepts, although some of them are beginning to build them in because they realize they are important. But even without the language support, you can be disciplined about it. In JavaScript, for example, you can say, well, look, if it's got an underscore in it, you're not supposed to reference it. It's internal, it's private. I think they have added a convention now.
Yeah, there's a hash convention now that actually enforces the interpreter to do so as well.
But tool support can really, really help. Particularly coming from a background working in C and C++, you're very heavily reliant on tool support, sometimes custom tools, to give you things that you would take for granted in a language like Java that you don't get in C++. You can do a lot of damage in C++ if you want to. So again, it's about the discipline, but it's possible to build things in, for example, pre-compilers, work with those a lot, and macros and other stuff to do some of this, take care of some of this stuff for you.
Are you familiar with CodeScene or SonarQube to sort of help
SonarQube,
help the teams remain accountable with some automated form of metrics or KPIs for code smells?
Yeah, I generally see it being abused by teams though. They don't use SonarQube because it's become very popular. In particular, so I've worked with teams where there've been people sort of working through lists of issues.
Ushered in to say,
fix this. So they go to SonarQube and go, what's the next issue on the list? And that's now I've not seen that work very well. I try to encourage teams to remain focused on the end customer and to remain focused on customer value. And wherever, it's not always possible, but wherever possible, when you are having to pay off some of that debt, it would be wrong to call it technical debt because that's not what really technical debt is, but to pay off, some of the issues in the code as part of delivering something of value for the customer, to always remain locked in that loop of red, green refactor, if you like, to always be locked in the loop of, well, we've got a change request here, or a bug fix if you have them, or a new feature. And as part of that, there are going to be some things in our code that are going to get in our way. I'm a big fan of Michael Feather's book, Working Effectively with Legacy Code.
Yeah.
It's one of the books I recommend as part of my CodeCraft training, because I think it's a much smarter way of approaching it. It just says, look, now you've been asked to make a change to the code. You've got to go and identify which pieces of code you're going to have to change. Now think about what's getting in your way. In particular, whether there are any tests that will protect you while you change that code. And if the answer is no, then your next priority is to do what you need to write those fast running tests. So you kind of, a lot of clients I work with, they've got, essentially, if you imagine all of their code issues and their lack of tests and all the other things they're dealing with and their slow builds, all that stuff, if you imagine it as a big mountain of ice cream. And there's two ways you can tackle the big mountain of ice cream. You can get a team, hand them some shovels and say, start shoveling the ice cream. The results of that are usually very disappointing, because it's not targeted. It's not targeted at making change easy, because it's not targeted at making changes. So the way that Michael recommends it is target what you're doing, particularly when it comes to refactoring and writing unit tests and other, dealing with other issues that are getting in your way. Target that at the change you've been asked to make. What will make that change easier and safer. So instead of having a group of people or a person with a shovel trying to eat as much ice cream as they can, but not delivering any value, not delivering any features, instead hand every developer a spoon and say, look, as part of this thing you've been asked to do, I'd like you to eat some of the ice cream. And if everybody gets into that habit of eating a bit of the ice cream, paying off a bit of that debt with everything they're asked to do, the mountain starts to come down much faster. But also it's targeted at the stuff that needs to be changed. We know it needs to be changed because we've been asked to change it. It also means you don't have to have that conversation with a manager or a customer about, we need the time to eat some of this ice cream.
And that's
the customer,
and that's the thing. Like you mentioned now, the customer and the manager. One of the big things, the big pressure points on engineering and the business side that I've observed is that once you start doing tests, the engineer might create this false fallacy that the tests are there to prevent the code from changing, because the tests are sort of snapshotting a past version of the code, whereas the business perceives the engineering department as, hey guys, I'm paying you constantly to do changes. Not to hold me, the business, accountable to past decisions that I've made about what features I thought I needed 6 months ago, but you're here to respond to the changes, because a response to a change creates more than projected value to the end customer. And that's really difficult to balance that of, I'm writing tests to make sure that if I change something, nothing breaks, but then you are breaking things by changing them, not the implementation, but the behavior itself. So then I want to be as flexible as possible to implement those breaking changes without doing any unintended accidental harm to the things I did not intend to change.
I think this often comes about because we make the mistake of thinking we need permission to do it. If you, and I've seen this so many times, if you are routinely, consistently, reliably, and sustainably delivering value for your customer, they will not ask, and it's none of their business. If you're not, that's when the problems start. That's when the micromanagers come in and the agile coaches and all the other people trying to fix the problem. The aim is to try and work yourself into a situation where the customer is happy and they trust you to do whatever it is that you're doing that's delivering value for them. Now, we've learned over many decades now, and we've learned, certainly going back long before I was born, that there are certain ways of delivering software that are more sustainable and more reliable than others. TDD is a good example of that. When, working at companies where teams come up to me, maybe I've done an internal talk or something on TDD, or on refactoring or any of these things, continuous delivery or any of these sort of code level practices. And they've said, oh, Jason, we would really love to do this, but our manager won't let us. And I kind of feel, well, that was your mistake.
Yeah,
you
asked.
Yeah. You asked.
So what's
the problem is again, we get back to, there's that transition, there's that learning curve. And how do you get through that learning curve without having to ask for permission? Because if you put people on a 2 or 3 day code craft course like mine, with the best will in the world, they're not going to master it in 3 days. So what can happen is they go back to their desk on the Monday morning and say, right, we're going to write tests for everything now. And then their productivity goes through the floor as they hit that learning curve. And it takes far too long to get back up. And then you're making it the business's problem.
Yeah.
Which is why it tends to be better to try and do these things under the radar. Like take one afternoon a week. And for one afternoon a week, for 10% of your time, just focus on doing it the way you're trying to learn how to do it. Your productivity will slow down, but it will slow down for 10% of the time. The rest of the time, get shit done. Keep earning that money, keep satisfying your customer. And then gradually, as you build confidence, that afternoon will become a whole day where you're like, so there's just one part of your week, whether it's TDD or refactoring or any of these skills, any practical skills at all, where you're not focused on trying to get stuff done. You're not focused on deadlines and doing things quickly. You're focused on doing them right, no matter how long it takes.
Because I've seen that zeal of, okay, that all in. I bought the book, I've read the book, guys, have you seen this book? And then they're all in, and then they're doing TDD, they're forcing everybody through code reviews to do TDD, and then the manager's like, what's this T something thing? I was
this is where a lot of things, not just test-driven development, but refactoring, agile, any of these buzzwords that you could care to mention, often they gain a reputation from people saying that they're doing it, but what they actually mean is we're trying to learn how to do it, is what they really mean. And that's when, like I said, none of this is compulsory. I do not say to anybody, you must do test-driven development. There are other ways of delivering reliable software, and there was a time before TDD when I was still delivering reliable software, but doing it in a different way, in this case, formal methods. But so I'm not going to mandate that they have to do it, but if you're going to do it, try and do it. Don't just say you're doing it. There was a study recently, I wish I had the link actually, that was done. Because normally when people in universities do these studies about software engineering, what they do is they go to teams or they go to companies and they ask a bunch of teams, what do you do? And the teams tell them, and they write that down and say, right, 40% of the teams say they were doing TDD.
There is enough skepticism in that.
What these folks did was they did the same thing. They surveyed and asked questions, but they also built a little plugin for Eclipse, and they observed what people were actually doing when they ran the tests, when they used the automated refactorings, etc. And what they observed was it's more than 9 out of 10 developers who say they were doing TDD were nowhere near it.
They're just doing test first, or like starting off and then on the refactor step, scratching their heads, staring at the screen. Not even close.
So we have to be wary when we talk about, and I don't want to I know that I train people in TDD, but I train people in other things as well. But any of these practices is going to get a bad reputation. And it's not me here saying TDD always works, you must always do TDD. What I'm saying is, if you're going to do TDD, do TDD. First of all, find out what it is. There's a big piece of advice, actually. At least look it up on Wikipedia. You'd be surprised how many people didn't realize that test-driven development involved writing a test first. So
the one thing that I see a lot of on LinkedIn is this heavy push of, there are people who are 80% don't do TDD, but then there are those 10% that claim that they do TDD and you must do TDD in order to be proficient and high quality. And then there's the other 10% which hate when they're being told that. Right.
They usually find me eventually. They tend to find me eventually. I've always been very clear. TDD is one of the things that I teach. And therefore, obviously, if you come to me for training in test-driven development, you're going to get training in test-driven development. I do occasionally, it's very rare these days, but occasionally you'll get people who are made to go on a course by their boss, who are obviously very reluctant. And I asked them if they could please just suspend their disbelief and try it. Just try it. Let's not argue about whether it's the right thing for you or not, because that's not up to me.
Yeah.
Try it, see if you can make some progress with it, and then go away and do whatever the heck you like. I frankly don't mind what people do. What I do mind is that software is reliable. So whatever you're doing to achieve software that is reliable, that end users can rely on. And from the point of view of my customers, I care that it can be delivered economically. I care how soon they can get it in their hands. I was talking about this with a client the other day, and they were sort of non-technical, so they were new to all of this, and they were saying, "What is this test-driven development thing?" And I was using the analogy of designing a kitchen, and I said, "Well, there's a number of ways you can design a kitchen. One way is to just build a shopping list of things you think a kitchen should have. It should have an oven and a stove and a kettle and a sink and a fridge and a freezer and so on and so forth. That's one way of approaching it. The problem we tend to find with that approach to designing solutions, which is what a kitchen is, a solution to problems, a set of problems, is that you can put your shopping list together and realize you haven't actually solved some of these problems. You haven't got what you need to make spaghetti carbonara, which is what you intended to do. So what TDD does, and most modern software development approaches are the same, in the sense that they start with figuring out who's going to be using this kitchen and what are they going to be using it to do. Mm-hmm. And with TDD, we could start with the simplest thing you can do in a kitchen. Well, I could get a glass of water. Okay, what do we need to get a glass of water? Well, you need a source of water, so a tap. We need somewhere for the wastewater to go, so a sink. We need a glass. Okay, so we need a tap and a sink and a glass to do a glass of water. Okay. And then you move on from there to a more complex example, like I'd actually like a cup of tea. Oh, well, you're going to need a kettle then as well. And a glass probably will shatter if you pour boiling water into it. So you might need some kind of ceramic mug. So you start to flesh out your design of your kitchen. What do we need to make cheese on toast? What do we need to boil eggs? What do we need to make? Until eventually you're talking about the 4-course dinner party for 6 people, and at which point your kitchen will probably be quite sophisticated. Now, the difference between a kitchen design and a software design is that, really, strictly speaking, a software design is the implementation. The code is the design. So when we give you your sink and your tap and your glass, you can have a glass of water straight away while we continue to design your kitchen, and we can see you having your glass of water. And if there are any problems, we can tweak that before we move on. So it's called evolutionary prototyping. So every prototype of the design is a working production quality system. Mm-hmm. That's what a TDD essentially is. It's evolutionary prototyping, which is you go through this very rapid series of prototypes. And every prototype is production ready, in the sense that we know that it works. It could be shipped if we had to. So at any point in time, we can give the customer their glass of water. We can give them their cup of tea. They can have their cheese on toast, and so on and so forth. They don't have to wait for us to design and build the whole kitchen. And this is from a business point of view, it's a very powerful thing. It means you get value potentially much, much sooner. You get your glass of water when you're thirsty, and not 3 months later when we built the kitchen.
Are you familiar with ATDD or BDD?
Yes. Yeah, variations on a theme, really. Same deal. I think there's many misconceptions about test-driven development. And one of the misconceptions is it's about unit tests, testing units. It's not. It's the same thing. You start with an understanding of what does the user want to do, what is the outcome they're expecting to get. So you go through the exact same exercise. There may be internal details on that. And so if we break it down and say, well, there are these 3 pieces to that jigsaw, so we'll tackle each piece on its own first. Something
that you mentioned, because Nick in chat is also asking about BDD and the kitchen analogy with the water. Mm-hmm. I've seen a lot of engineers, and sometimes I do it myself, and I don't know, I catch myself doing this. Sometimes when I start writing a test, and I've gotten like a really high level overview of what the behavior should be.
Yeah.
It's this idea of someone wants to drink water. And then I start writing a test that goes something like, how will you quench your thirst without a glass? and to simulate at the prototype, okay, what will you do if I don't give you a glass? And
Fake it till you make it.
And yeah, exactly. And to explore, like, what do you need from the, to explore the space of what is the glass for exactly? At which point do you need the glass? What is the minimal amount of glass that I can give you so that you...
Well, if you wanted to focus on, if you just wanted to focus on the tap, for example, you could say, well, look, I've got a bucket here, so I'll pretend that's the sink. And you can use your hands for now. And we'll do the glass bit later. But if you're just fitting the tap, you don't need a glass and a sink to fit a tap. Well, generally you would fit a tap to a sink, but you can normally sort of focus on one part of it and say, well, look, there are other parts to this, other things that need to be in place. But we can, I mean, even at a production level, I've worked on websites where the deadlines were so unrealistic that we said, well, look, all we can really do by then is this. But I've had multi-million-pound websites go live where we were employing database administrators to squirt the data in every night manually from spreadsheets until we could build data entry to get that information in there.
See, that's the thing. Jason, do you mind if I just go back to the analogy a little bit?
Sure.
Because when you apply these forces, like a database expert or like an architect, or maybe an ivory tower architect that has pre-planned and pre-designed the entire system, an engineer doing TDD might get in trouble sometimes when the architect gives him a perfect plan for a kitchen with a sink and a tap, and what they created was a bucket, because they said, this is what you need. Based on your acceptance criteria, you need a bucket, but you've also designed me a whole kitchen. What should we do?
Well, you would hope that an ivory tower architect would not be involved in that process. That if you have people with architecture skills, which you would want, really, ideally, most of the developers to think that way, that would be ideal. To be able to apply that kind of thinking as they go. But in those situations, the person it's always quite easy if you're putting working software in the hands of end users on a regular basis. It's quite easy to reframe the debate so that it's essentially the architects arguing with the customer about what they need. So you need to get the customer on your side, and the best way to get the customer on the side is to give them something of value. Well, the architect, if they're that kind of PowerPoint jockey style of architect, I think you're implying, then they're producing nothing of any value for the end customer. They may well have their own internal champions and their own internal sponsors who are keeping them in place. This is particularly true in larger organizations that have architecture teams or architecture departments. I've never come out of a situation, because I was an architect once upon a time. So I've never come out of a situation where the architect has won, because in order for them to win, the customer has to lose. Yeah,
because it's too rigid. They have to snapshot the past.
So that's not to say that I don't believe that architecture requires a lot of thought, but my own experience of architecture is that it's a continuous activity. It's going on all of the time, like testing. It's going on all of the time. And really, ideally, what you want as a team, there may be someone on the team who specializes in software architecture, who knows all the patterns and all the metrics and all of the different styles of architecture and knows how to do it in any tech stack that they're going to use. But ideally, you want the developers 80%, 90% of the time to be able to make those decisions themselves. Otherwise, the architect becomes a bottleneck as well, as everyone's seeking permission. Generally speaking, if the developers are finding that they're often having to seek permission to do things, then something's gone wrong. They should be able to they should be able to trust them to make those decisions. If you're an architect and you don't trust them, then it's time, as I did, many years ago, it's time to roll up your sleeves, put on your apron, and go sit with the developers and help them make the decisions, help them make better decisions.
Jason, being conscious of your time, this was really helpful. Thank you for going so broadly on the topic. I didn't have to guide much, so it's always a pleasure to have somebody who is well spoken on their topic and the craft of choice. You've made it your whole career, and I commend you
now,
for that.
yes, but I will stress once again before the comments starts. I am not. This is stuff that I teach and I engage with teams on, and that's my business. That's my job, and I've made it my business. I am not mandating that you have to do any of these things, but if you would like to do them, then and you are struggling to do them, by all means get in touch. There I can help. If you don't want to do them, you and I don't need to engage on that topic. So please don't email me, don't contact me, don't tweet me, don't tweet me. Say, but I don't want to do test-driven development. Fine, don't do it.
So for those
I will lose no sleep over that.
For those that genuinely want to, what's the best way to get in touch with you?
I'm really easy to find. I'm jason.gorman@codemanship.com, very easy to find. Or you can go to codemanship.com. You'll find details of the training and coaching that I do. I'm just Jason Gorman on Twitter and on Mastodon. If you're on Mastodon, jason.gorman@mastodon.cloud. And I'm just Jason Gorman on LinkedIn, available for weddings and bar mitzvahs.
I'm going to put a link up in the corner for our viewers.
Cool,
so you can check them out later.
Yeah.
I would like to wrap it up here. So for you, Jason, thank you for your time. It was a pleasure having you on. Thank you.
No, my pleasure.
And for the viewers, thank you for being here with us. It's always a pleasure to share TDD knowledge and craftsmanship knowledge in general, which is now becoming a common theme on this channel. If you've had any aha moments, please don't hesitate to share them. I would love to hear your feedback on comments on LinkedIn. Reach out to me or reach out to Jason, and subscribe, and see you next time. Thank you.
Cheers.